shortcuts for changing f of x equals ax squared plus bx plus c into f of x equals a times x minus h squared plus k. So the idea here is there a quicker way to go from this general form into this standard form? I guess specifically you would ask, is there a way for me to tell what h and k is by just looking at the values a, b, and c? Now, while I just say h and k over here, I really mean a, h, and k, but a is easy to figure out. A is just a doesn't change. So what's the real relationship between h and k and this a, b, and c? So to find a shortcut formula for h and k, we complete the square on the general form. So stay with me. I'm actually going to do this pretty quick. You should be able to do this, but I don't want to spend all day going over this. So follow me down the rabbit hole. I'm going to do exactly the same thing that we just did. F of x is equal to ax squared plus bx plus c. And the first thing I'm going to do is I am going to move my constant off to the right. I'm going to ignore my constant. The second thing I'm going to do is I'm going to factor out that leading coefficient. Now, this is a times the quantity x squared plus. How many times does a go into b? I don't care. When I pull it out, I just get a b over a. So that's my next significant feature. And I know it's b over a because when I multiply this a back through the distribution here, I'll get the ax squared. And then when I multiply a by b over a, the a's will cancel and I'll get this b back. So then in step 3, we're going to, what did I call step 3? I forget. Complete the square inside the parentheses. So for x squared plus b over ax, we take this value, we cut it in half, and that gives us b over 2a, and then we square it, and we get b over 2a squared, which is b squared over 4a squared, and that is the magic number, whatever that turns out to be, that we add in. But to keep the equation balanced, we have to subtract it right back out. So we then have f of x is equal to a times x squared plus a b over ax plus a b squared over 4a squared minus a b squared over 4a squared plus c. We then rewrite this. This is a, this is x squared plus b over ax plus b squared over 4a squared plus a times negative b over 4a squared plus c. And then this is a perfect square. Perfect. And it factors as a plus b over 2a squared. And then here I need to rearrange this. This is plus c minus a b over 4a because I'll get 1 power of a to cancel. And then if I get a common denominator, this becomes a x plus b over 2a squared plus, if I give this guy a 4a over 4a top and bottom to get a common denominator, this will become 4ac minus b. Oops, I left off my square. I'm missing a square there, folks. Square. All over 4a. And this is supposed to be equal to a times x minus h squared plus k. So I can identify these parts. H and k, well, k is this piece here, and I need to actually take this and rewrite it one more time. I need this to be subtraction here, so this is minus a negative, or I want the opposite value. And so then our formula shortcut is for f of x equals ax squared plus bx plus c, a equals a, h is equal to negative b over 2a, and k is 4ac minus b squared over 4a. Now k is a little bit complicated, but h is easy to get. This one is the gem. That's the one we really want. So we would note that this is the vertex shortcut. That is to say, h is negative b over 2a. Now, instead of memorizing this formula, k equals 4ac minus b squared over 4a, which you can memorize, this is also for y equals f of x. This is the output when the input is h, that is to say, f of h equals k, and so k is also f of negative b over 2a when you plug that value in. So the other shortcut here is k is just whatever the y value is that goes with the h vertex value. And that's known as the vertex shortcut.